Hello, welcome to my channel. I am Ameya and today we are going to see a simple problem in Ansys mechanical APDL. So this is the problem which we are going to solve. It's a simple beam fixed at one end and having an axial load of P. L is the length property given, E and A. So modulus of velocity and area. So let us start. So opening the Ansys mechanical APDL. First thing, we will start with a preference. So you can just click on preference, structural. Okay. So what preferences will do is it will filter the requirements as per the selection. So if I am selecting a structural, my element properties, loading, meshing, everything will be filtered as per the structural problem. So second step is pre-processing. Now most of the part of your Ansys creating a problem and giving inputs, all things will be given in the pre-processor. So we are going into pre-processor now, starting with element type. Now which element to add? We will be solving this problem using 1D analysis, basic analysis. So you can select the link element and select the link 180. Okay, why link element? Because there is only axial load and link element is designed to have axial load. Okay, there is no bending involved. In problem also we have seen there is no bending, it is just the axial load. So we will be selecting a link. So close. So link element don't require any real constant. You can go to the material property, material models, structural, linear, elastic, isotropic. Okay, so now what we are doing here actually, that is what we need to understand. So we select a material, we assume that material to be having a linear property, and because we are doing a structural problem, the elastic property and the isotropic assumption is very important. We are assuming that material behaves same in all directions, and in that we will be entering our modulus of elasticity. Now, the important thing here we need to understand is whatever inputs we are giving, make sure those inputs are in single unit format. Okay, so if you are following mm, everything should be in metric format. So this GPA we need to convert into Newton per mm square. So let's see, I will enter 2E5. So that is basically 2 into 10 raised to 5 Newton per mm square. PRXY is your Poisson's ratio. Generally for metals it is always 0.3. So we will just follow that 0.3. Say OK. A material property will be added. You can see the material model definition. One material property is added into my problem. You can exit this now. So we have the material property now. You can go to sections. We have defined the link element, so that's why we will define section for the link element. Go to link element, add the section, give the section ID. This is the first section which we are defining, so that's why it is 1. You can label it, say SQ1 square 1 for our reference, and the area. Okay, now what will be the area? 25 into 25, so it will be 625. So area will be 625 mm square. Okay, we will not be entering in any mass property because mass is not involved in this axial loading. There is a tension key. We are assuming this to be tension and compression. So basically my beam or the link element will take both tension and compression. If you have planned your problem so that it will only take tension and compression, you can select that. We are not changing it right now. We are taking tension and compression. Okay, so element type is done, material property is done. Now we have to go to modeling. Now what we will model for this, we will model this bar, but we will not be creating a 3D structure, we are creating a 1D structure. So we will take a point at this location, a fixed location, and we will take one point at this location. Okay, with the difference of L is 500. So let us create key points in active coordinate system. Don't worry about the key point number, it will be assigned by the system. So I am creating first point at 0, 0 and second point at 500. Okay, So you have 2 points, make a line between those 2 points. I will go and create a straight line. Okay, so everything which you enter into the Ansys is having some numbers. Okay, so I am just switching on the plot numbering from key points and lines. Okay, plot multiplot, that will give you the line and nodes. So that is plot multiplot is basically a refresh command. It will plot everything which is drawn in my screen. Now, after modeling, this is the only model which we are going to create. We will apply section on this, then it will get converted into a 3D model. So meshing is my next step. Now in meshing, we need to understand 3 steps. There are 3 basic steps of meshing. One is the element attribute, where we select the property of an element. Then there is a size control, where we decide size and number of the elements, and then we go for a mesh. Okay, so here we only have lines for now, so I will select lines and I will set attributes for lines. Select a line. Okay, it will ask for the property. Material we have one, section also we have defined one. There are no other sections in material, that's why it is only showing one here. I will say okay. Now these properties are applied on this line. Now we have to do the sizing part. So I will go to set, we have lines only. So go to set lines, select a line, okay. Here you have 2 windows. One will give you the element age length and one will give the number of element division. Depending upon the given data, you can go either one of them. So if my element is 500, total length is 500, I can enter here 100, so it will create a 5 elements. Okay, so it will be equal length. And if you don't know the length, you just want a specific number, you can select number of elements to be 10. It will create a 10 equal length of the element. I will say okay. If you see in the front view, you will get the different 10 different lines. This is called the sizing. Make sure you are not meshing with this. This is not a meshing. Don't get confused with meshing and sizing. If you get the separate lines, a gap between 2 lines, this is only the sizing part. Still the meshing part is remaining. So again, I will just go to mesh tool. I will select the lines, go to mesh, select okay. Then you can go to plot multiplot. If you see this white dots, those are basically my node points, and this will make sure that my part is meshed now. Now, what happened to my section? I am not still able to see the section. So where is my section? You can go to plot controls, styles, size and shape, and you can select the element display on. Okay, and that will give you the element display. Okay, so this property is applied on my 1D line. That's why it is 1D problem, but it is basically a 3D structure. Okay, now after meshing, the last is the loading part. So you go to load, define loads, apply structural displacement. Now why displacement? What kind of loads are there in this problem? This is a fixed area, fixed part. One side is fixed, one side is having load. So what do we understand by the fixed part? It is having zero displacement. So that is what we need to do here. So you can go to define loads, apply structural displacement, then select the key point, select the base key point, say OK, and all degrees of freedoms will be fixed. If you don't enter the value, it will be assumed to be 0. So all degrees of freedom to be fixed, you will find these small arrows which are generated in all 3 directions. That will make sure it is fixed. Then after displacement, you will go to force movement, select the key points, select the last key point, say OK, and in which direction you want to apply a force. Obviously it's axial load, so you will go with X direction. Now the force value. It is very important to give the sign for the force value. If it is going on right hand side, it will be positive, that is tension, and if it is going on left hand side, it will be have a negative value, which will take the compression. In this problem, we have load which is going in the right hand side, which is creating a tension. So that is what my value of force is. So it will be 10,000. Why 10,000? The given load is 10 kilonewton. We need to convert it into Newton. Okay. So always make sure whatever you are giving input to the Ansys, it should be in same unit system. Now this is how we do the pre-processing part. What we have done in preprocessor: the element type, material property, sections, modeling, meshing, and loads. Okay, these are the basic things which we need to do in pre-processing. Now in solution, you can go to solve current ls. Okay, it will appear solution is done. Current ls stands for current loading system. So whatever loads I have defined, system will be solved for that current loading system. Okay, that is the only part we do in solution. You can go to general post processor, plot result, deform shape. You can say deform plus undeformed, and you can see there is a deformation. If you want to see the animation, you can go to plot control, animate, deform shape, deform plus undeformed. It will show you the animation. Okay, you can just change the number of frames, faster, slower, only forward, all those settings you can do. This is the deform shape. If you want to plot the contour, you can go to nodal solution, contour plot, nodal solution. I want to find the displacement, say OK, X component, then you will get the displacement. Okay, so maximum displacement is 0.4, you can 0.04, you can verify the answer. I have solved it for you. So this is 0.04 u2. Okay, so it matches with our answer. Now if you want to have the list, you can go to list results, nodal solution, DOF, X component. You will get list, and this list is basically a displacement at each node. We have created 10 elements, so there will be 11 nodes, and you can go through the displacement which is coming. Okay, and then what we have to do is, if you want to animate this, you can go to plot control, animate. uh, you have deformed results, DOF, UX. Okay, it will animate the deformation. Okay, if you want to save the output, you also have those options. In coming videos we will discuss those options, how to save the output, how to save the plots, all those things, how to save the animation, all those things we are going to see in coming videos. So this is how you basically solve the simple bar problem with the axial load in 1D for the Ansys mechanical APDL. If you like this content, do subscribe my channel, follow my channel, and share a word about channel with your friends. Thank you for joining.